Okay, we're on Module 4, Lesson 9. This is getting us ready for Lesson 10, the Pythagorean Theorem. It's going to help us understand what perfect squares are and how to do square roots. So the directions tell us that the areas of the squares, that's the key word. These are squares. So if you remember from earlier in this module, squares have all sides equal. So when I put the width down and I put the height down, they should be the same number because a square has 4 equal sides. So they've given us the area. So what we're doing is we're saying what number times itself gives me 9. And that would be 3 times 3. So it would be 3 feet by 3 feet. So you don't know it yet, or you might know it. We're really just taking the square root of this number because we need to know what number times itself, since these have to be equal, give me 9. So remember, areas in square feet, but when we do dimensions, it's just feet, because 3 times 3 is 9. Feet times feet are feet squared. So what about number 2? The area is 1 foot squared. So what number times itself gives me 1? And that would be 1, right? So 1 foot by 1 foot. 1 times 1 is 1. Feet times feet. Feet squared. So the square root of 1 is 1, just like the square root of 9 is 3. Next we have 81. So what number times itself gives me 81? That would be 9. This time it's yards. So 9 times 9 is 81. Yard times yard, yard squared. So the square root of 81 is 9. 144. Maybe some of you know that, maybe some of you don't, but it's a good time for me to show you how to find square roots on the calculator for future classes, and in case Alex gives you a problem that you get to use a calculator. So here's the x squared button that we've used to put an exponent of 2, and right above it, look at that, right above is a square root. So in order to access anything that's above a button, we have to use the blue key second. So see how all these things are in blue? That means they need to be preceded by the second key. So we do, let's turn on the calculator, second, and then hit your x squared button, and it gives you the square root. Type in 144, close the parenthesis that's given, and we can see 12 times 12 is 144. So this would be 12 feet by 12 feet. So when we do the square root, it says what number times itself is 144, and it gives us 12. So that's what square root means. What number times itself gives us 144. And it has to be a positive number because square roots want the positive square root, because negative 12 times negative 12 is also 144, but when we use the square root symbol, they want the positive square root. So this one, Alex would have to give you a calculator for if it was on the test, because 30 is not what we call a perfect square. A perfect square means there's a whole number times itself, or a rational number times itself, which will give you that. But there is not a whole number or integer times itself, which will give us 30. So this one we have to use a calculator. So we do the same keystrokes. We do second, hit the x squared button, see the square root, 30, and keep looking at your screen so that you know to close the parentheses. And the directions say round to the nearest thousandth. So it goes after the decimal place, tenths, hundredths, thousandths. So that's asking us for 3 decimal places. So tenths, hundredths, thousandths, and we say 7 followed by a 2, stay 7. So this would be 5.477. And since it's a square, we know this one also has to be 5.477 because the square has equal sides. And this one is inches squared, so it would be inches. So that's how you use the calculator on something that's not a perfect square. All of these were perfect squares though. They all had some whole number times itself that would give them that. 30 doesn't. 5 times 5 is 25. 6 times 6 is 36. So we knew it was in between 5 and 6, but we had to use a calculator. Okay, let's go on to the next page. Okay, on the preceding page, problems 1 through 4 were called perfect squares. When you multiply the 2 sides of the square, you will get the area of the square. Problem 5, though, was not a perfect square because we are not able to find some integer that when multiplied with itself will equal 30. Like I said, 5 times 5 is 25, 6 times 6 is 36, so that's why it's not considered a perfect square. So what is a perfect square? It's the product of a rational number. They use the word integer, but it really should be rational number. I'll tell you why in just a second. Multiplied by itself. So square root of 36 is 6. But look at this, square root of 1/9. Square root of 1 is 1. Square root of 9 is 3. So that's why we need to use the word rational number, because 1/3 times 1/3 is 1/9. 1 times 1 is 1. 3 times 3 is 9. So it's the product of a rational number times itself. So 6 times 6, 36. 1/3 times 1/3, 1/9. So that's the definition of a perfect square. The symbol for square root is this. For example, in problem 1, square root of 9 is 3. Square root of 9 is 3. Write a similar statement for problems 2 through 4. So 2 would be the square root of 1 is 1. Of 1 is 1, because 1 times 1 is 1. For 3, the square root of 81 is 9. And last but not least, 4, the square root of 144 is 12. Okay, so let's take a look at square root 30 from number 5. So square root 30 is not a perfect square, but it does have a square root, which is approximately 5.48. So if I rounded this to 2 decimals, that would be 5.48. We will learn about these types of non-perfect squares later. So what about square root of negative 49? So square root means what number times itself gives me negative 49. So usually students go, oh, negative 7. Well, negative 7 times negative 7, a negative times a negative is positive. So we can't write negative 7 for this. So this one is, we call it a non-real number. Excuse me. On the next page, they write not possible. So it is not possible because in the real number system, but you'll learn later that this is actually 7i. You'll learn that in Math 120 if you're going to take that. So there's no number times itself which will ever give me a negative. Every number times itself always gives us a positive. 7 times 7, positive 49. Negative 7 times negative 7, positive 49. I really should have those in parentheses. So later on, they're going to have you write non-real number, or once you learn the imaginary numbers, they'll have you write 7i. But for right now, we're just going to say it's not possible. There's no real number times itself that will ever give me negative 49. Okay, let's go to the next page and practice our square roots. For the following, find the square root, give an approximation to the nearest thousandths when necessary. In some cases, you may need to write not possible. So square root of 4 is 2. Because, 2 times 2 is 4. Square root of 100 is 10, because 10 times 10 is 100. Square root of 36 is 6, because 6 times 6 is 36. So if you want, you can shut off the video and try those next 12 on your own, if you'd like to try those first by yourself. And then come back and check them with us. Square root 121, if you don't know the square root of that, you'd hit second, x squared, 121, close your parentheses, and it is 11, because 11 times 11 is 121. Ooh, 40. Is there any number times itself which will give me 40? No, because 7 times 7 is 49. 6 times 6 is 36, so we skip 40. So let's go ahead and put that in our calculator. Second, x squared, 40, and it said nearest thousandth in the directions, so 6.324 followed by a 5 says make it 5. So 6.325. Square root of 0 is itself. Square root of 16 is 4. 4 times 4. Square root of 64 is 8. Here's one that's not possible, because there's no way to get a negative number, because negative 3 times negative 3 is positive 9. Square root of 400 is 20. I'm just going quickly because we're almost out of time. This is 60, 36.